Good evening. Today we are joined by Dr. Elizabeth Phelps, the Pershing Square Professor of Psychology and Neuroscience at Harvard University. Dr. Phelps is a distinguished cognitive neuroscientist. Her research focuses on the intersection of memory, learning, and the role emotion plays in our mental lives. She is a recipient of the 21st Century Scientist Award from the James S. McDonnell Foundation, as well as the Distinguished Scholar Award from the Social and Affective Neuroscience Society. She attained a master's and PhD in psychology from Princeton University in 1986 and 1989, respectively. Since then, she has served on the board of directors of the Association for Psychological Science and the Society for Neuroeconomics. She has also served as president for both organizations. In short, Dr. Phelps is a trailblazer in the field of cognitive neuroscience and has received numerous awards and honors throughout her career. Please join me in welcoming Dr. Phelps, who will present a presentation entitled Race in the Brain: Insights from Neural Systems of Emotion and Decisions.
My first visit, and I have to say it's pretty impressive. So I want to sort of give you an overview of the research we've been doing on race bias in the brain. It's not my primary area of research. My primary area of research is the cognitive neuroscience of emotion and learning and memory. But I got into this because emotion is relevant to how we respond to race groups in the United States. And I'll sort of outline for you my path as we get into the talk. But I want to start with sort of a simple observation. So in 1933, two Princeton psychologists showed that most people had fairly robust stereotypes that they were quite willing to endorse. And so, for instance, in 1933, just by asking individuals, they got the majority of people to say that Jews were shrewd and mercenary, and Negroes were superstitious and lazy, and Italians were dirty and unreliable. A lot has changed since then. Today, if you were to ask Americans how they feel about different social groups, they would hardly use that sort of array of derogatory adjectives. Since that time, there's been this marked decrease in the endorsement of negative race and other social attitudes in the US, and the vast majority of US citizens express egalitarian views. Nevertheless, as we all know, there's still evidence that race bias persists. So these are just, a few images from what was happening a few years ago in the Black Lives Matters movement. In legal decisions, you can go into many, many examples of race bias. So black males are 6 times more likely to be incarcerated than white males. The likelihood of jail time is higher for black males with similar offenses. Hispanic and black males receive longer sentences than white males for equivalent crimes. And this is the work of Jennifer Eberhard at Stanford. Regardless of your race, the more Afrocentric your features are, the harsher the sentences that you receive. And if we look at sort of the likelihood of getting the death penalty, only for the most severe crimes is there roughly parity in whether or not you receive the death penalty if you're black or white. For the more modest crimes, you're much more likely to receive the death penalty if you're black. So there's abundant evidence that unintended race bias influences legal decisions. Some have argued this is due to socioeconomic status. If we look at socioeconomic status as a factor, we see in only the highest decile of economic wealth do we see equivalence for blacks and whites in terms of the likelihood of imprisonment and incarceration. And if you do systematic studies of things like force, you tend to see these biases as well. But they're not always that blunt. So even just the way we talk often shows evidence of bias. So here's just an example from Hurricane Katrina in New Orleans. There's 2 pictures here of individuals who are getting food and wading through the water. And if we see how they're described, this young man is looting a grocery store. Whereas this nice white couple, they were so lucky they found bread and soda at the local grocery store. So you can see just even these subtle ways that race bias comes into play in everyday life, in spite of the fact that most people express and have egalitarian views. So how do we make sense of the difference between our beliefs and our perceptions and our actions? So I want to just give you a sort of example from perceptual psychology. So this is just a demonstration of what's considered a perceptual illusion. So if I'd asked you which one's longer, you'd say the one on the left. Okay, now you know they're the same size, but which one looks longer? The one on the left, right? So you know this is a perceptual illusion, right? You know that the one on the left and the one on the right are equal in length. But no matter what you do, you can't see that when you look at this. And this is because you have a lifetime of perceiving objects in the world, and we have ways that we perceive depth on the 2D images that come to our brain. This is perceptual learning. Perceptual learning allows us to perceive depth, and those cues can be used to trick us at times. And so this type of perceptual learning is well known. It's automatic. You don't have control over it. And it's there whether or not you try to control it or not. And this doesn't surprise us, right? This is how we perceive the world. If you're an artist, you take advantage of this in your artwork. You could argue, however, that we also have, so learning affects our perceptions even when we're not aware of its influence. You could argue the same thing is true for our social perceptions, that learning about cultural stereotypes can affect our perceptions and responses to others even when we're not aware of its influence. So regardless of your beliefs, you grew up in a culture that has certain cultural stereotypes. You've learned what these stereotypes are. They've been practiced over years, in TV that you've seen, in news reports, et cetera. And that is going to influence your perception whether or not you are aware of its influence. And even if you try not to let it influence your perception. So social psychologists define two types of attitudes. One, explicit attitudes reflect your conscious beliefs. The other, implicit attitudes, are expressed through our responses and actions without our conscious effort or control. And we believe these may reflect affective or emotional associations associated with cultural stereotypes for our culture. So what I want to talk about today is the latter category of this, these implicit associations, the ones that seep into our language in news reports and the judgments we make about others, and what we know about the neural systems that underlie those and how that can teach us something about how they come about and how we might change them. So I'm going to give you a little outline of what I'm going to talk about today. First, I want to kind of tell you how we sort of built a neural model for the representation of implicit attitudes in the brain and where this came from. And I'm focusing here on implicit race attitudes. It would be a different neural model if I'm talking about implicit gender attitudes or age attitudes. And then I want to ask the question, can we take advantage of our understanding of the neural circuitry of implicit race bias to enhance our understanding of race interactions? What can I learn about race interactions from knowing something about the neural systems that underlie it? And finally, I'm going to ask the question, I'm going to give you the little heads up right now, you're going to be disappointed in the answer here. But the last point I'm going to address is how might we change race bias in the brain and behavior? I'm disappointed because I'm not going to give you one really great answer. All right. So first let me tell you a little bit about how I got into this, to investigating this topic. As I mentioned, my expertise is emotion learning in the brain, particularly threat learning, how it is we learn things in the environments that are potentially dangerous to our survival. And the type of techniques that we use to study this are drawn directly from animal models of simple threat learning. This is sort of how Pavlov described learning things by association. So here's a slide I borrowed from my longtime collaborator, Joe Ledoux. And what Joe does is he studies rodents, and he does these simple threat learning where you pair a tone, a neutral tone, which has no particular effect on the rodent with a mild shock to the foot, and then the tone itself comes to elicit a range of responses consistent with fear, just like Pavlov described, learning through association. Joe Ledoux, Mike Davis, other neuroscientists have shown that the amygdala, here in red, the amygdala gets its name from the word almond. Sorry, I keep pushing the wrong button. So you can kind of see that here. And this is what the pictures I show you will look like. Here's the amygdala, the sort of dark area right here. It's very small. They've shown that the amygdala is necessary for the acquisition, storage, and expression of these simple threat associations. So it's thought to be somewhat of a threat detector in the brain. When there's something threatening the environment, it signals that it's present. So when I first started working on this topic, I wanted to do something very akin to what Joe did in humans, and by humans I mean undergraduates. So we brought people into the laboratory, gave them a mild shock, so showed them a neutral stimulus, a blue square, paired it with a mild shock to the wrist. After a few pairings, the blue square itself came to elicit a range of responses. The primary one we measured was sort of sweating, which is indication of autonomic nervous system arousal, the skin conductance response. And what we found, not surprisingly, here using brain imaging techniques, if I'm looking at the blood oxygenation level signal to a stimulus that was paired with shock versus one that was not, we see activity in the amygdala. If I look at patients with amygdala damage, I see something like this. So here, this is the skin conductance response to a shock, the autonomic arousal response to the shock itself. Here's the blue square that predicts a shock. Here's a healthy participant. They show an anticipatory response. This thing now predicts a potential danger. A patient with amygdala damage does not. This is very consistent with what they show in rodents. The amygdala seems to be a learned threat detector in humans as well. And this tells us the human amygdala is necessary for this physiological or physical expression of the learned aversive response and threat conditioning. So here is a woman who has bilateral damage to the amygdala. We showed her data, it looks something like this, the real data, not the cartoon version of it, and we asked her to comment on what she thought. So I'm going to play for you what she said.
I haven't noticed that there's anything odd about my reactions to normal lifestyle, life threats. My fear element seems to be, to me, in my head, normal. I've never noticed anything odd.
And how do you feel seeing these results? And how does that make you?
I'm dead. I think that it's probably absolutely correct. I know I don't sweat. I knew that there was an anticipation that the blue square was going to, at some particular point in time, bring on one of the volt shocks. But even though I knew that, and I knew that from the very beginning, except for the very first one where I was surprised, I really don't think that I mean, I knew it was going to happen, but that was my response. I knew it was going to happen. I accepted that it was going to happen. So I learned from the very beginning, it's going to happen. Blue shock. Happened. I turned out to be right. It happened.
So I think as she dramatically demonstrates, even though her body is not telling me that she's learned this association, she has perfectly good explicit knowledge of that association. And this is in part because she has a detect hippocampus and pretty decent memory. But this dissociation we saw in patients with amygdala damage between the sort of indirect physiological expression and sort of the knowledge of the circumstance made us think of my then colleague, Masri Menages, and now my current colleague at Harvard, work on implicit bias. So at the time, both Masri and I were at Yale, and she was doing this work showing this dissociation between what people tell me and how they respond on more indirect tests. And so we thought, well, could it be the case that the amygdala is underlying this indirect expression of implicit bias, but not the explicit expression? So we asked the question, does the amygdala play a role in implicit race bias? To do this, This was a very old study in the days in brain imaging. We brought in some white American participants, Yale undergraduates primarily. They were shown pictures of unfamiliar black and white male faces. When they were actually shown the pictures, they were just asked to indicate, is the face repeated or not on each trial. Afterwards, we gave them 3 tests. One was just a measure of explicit race attitudes. How do you feel about race? What are your views about race? One was a measure of implicit race attitudes. It's very common these days, the implicit association test. I'll show you that in a second. And the last was a physiological assessment of the affective response. It was a potentiated startle. So if I were to do this, some people might have jumped a little, I don't know. If you were to hear a loud noise like a car backfire and you're walking down the street in the middle of the day, you jump a little bit. If the same thing were to happen late at night when no one's around and you're feeling a little nervous, you would jump even more. The startle reflex is enhanced or potentiated when you are in the presence of something you find threatening or negative. And so we measured this in the laboratory by putting electrodes on your eyes, measuring how hard you blink when we play a loud noise in your ear while you're watching a black or white face. So how many of you know the implicit association test? Do you want to do it? So many of you, but not all of you, do you want to do it? I'll just describe it. Should we do it or describe it? I don't know. Do it? Okay. This is how we do it as a team. I need a timer though. Do you have a time? Okay. So the way this test works, you're going to see. So you see this start up here. When I start the screen, you're going to see coming up one at a time, all the way around here in a circle like this, either a word that means something bad, or a word that means something good, or a black face or a white face. What I'm going to ask you to do, if we're going to do it as a team, as a group, I'm going to ask you to touch your left thigh every time you see a white face or a word that means something bad, and to touch your right thigh every time you see a black face or a word that means something good. Okay? And I'm going to say go. When like it's petering out, that's when we stop. You just stop. It's a judgment call on your part. We're not doing the actual test. Okay. Is everybody ready? Okay, here we go. That's really, okay. Oh, yeah, it's much faster than you can go. All right, this is not working because we cannot hear your taps. Should we start again? Let's start again. Okay, now you have an idea how it works. Okay? So we need to hear, if he's going to time you, he has to be able to hear you go like this. Okay? All right. Are you ready? Okay. So left thigh, white face, word that means something bad. Right thigh, black face, word that means something good. Here we go. It's going to go faster than you could go. We're just waiting to see when you catch up. Okay? Sorry, I didn't tell you that the first time. Yeah, you got. Don't tell me yet. Okay, just mentally note it. You screwed up?
Yeah, I screwed up.
Okay, we got experimental error here. Experimental error. You know, you have to report that in the papers. Okay, now we're going to do it again. This time, left thigh, black face, word that means something bad. Right thigh, white face, word that means something good. Okay? Ready? Here we go. All right. Okay, we don't actually have data to present to you. But what I'll tell you, so doing a task like this, there's different ways you do it. The vast majority of white Americans will take longer when they have to pair black with good and white with bad than the opposite. For black Americans, they actually as a group show no difference. But what they find is different subgroups of black Americans show show more pro-black bias, others show more pro-white bias. The Yale undergraduates who were black tended to show a slightly pro-white bias, whereas the local towns, the black people who lived in New Haven that were not from Yale tended to show a pro-black bias. So that in our first study, we only investigated white participants, but that's not all of our studies. So this particular test, you might be saying, well, you did this one pairing first and then you switched it. What do you do the other way around? This has been done every way to Sunday. If you don't know this website and you're interested in implicit bias, I recommend it. There's been over 1 million people that have taken the implicit association test on this website. They can break it down by political district, anything you want. They have so much data at this point. And it allows you to look at biases that are not just about race, about gender, about sexuality, anything you want. And they can start to track now how it changes over generations and by other demographics as well. So just for your benefit. All right. So what we found in our white American participants was essentially what we expected for this study, which is it took participants longer to respond when black was paired with good and white is bad than the opposite. When we looked at the startle eye blink, again, now I'm just doing a physiological assessment of the affective response you have. These white American participants were startled more when they were looking at a black face than a white face. We then compared our 3 measures of race bias, explicit, IAT, and startle eye blink, with activity across the brain, particularly the amygdala. And what we found is here, I'm just looking at the amygdala. What we found is a correlation between the strength of your pro-white bias and the amount of amygdala activation you showed when looking at a black versus a white face. And that was true for both of our implicit measures, but not for our explicit measures. So this was a very early study in the days of brain imaging. The N was small. It wasn't the most powerful scanner. We didn't actually see a difference overall. Other studies since then with better techniques have seen that. But nevertheless, it showed this association. Here I'm plotting the same thing, just showing you, saying show me regions of the brain that correlate with the strength of the implicit association test or startle eye blink. And I see the amygdala in both cases. So this was the first study on looking at race in the brain, showing what we expected it would show. It was very early days, a relationship between implicit bias and amygdala activity when looking at black versus white faces. The second study that was published asked an interesting question. What happens if you're not even aware the faces are being presented? So this study was done by Will Cunningham, who was on the first study as well. And what he did was he presented these faces surrounded by these stimuli we call masks, so they disrupt the perceptual processing of these faces. And he presented the faces either so quickly that individuals were unaware of seeing them, or long enough that they could actually see those faces. And what he found in the amygdala was that, so here I'm plotting the dashed lines are the subliminal unconscious response in the amygdala. The solid lines are the conscious response. So he replicated our results. He saw greater amygdala activation to black versus white faces. But he also saw that this was stronger and actually correlated more strongly with AIT if the faces were presented so quickly that individuals were unaware of seeing them. So this led to the question, what happened with awareness? Were there other brain regions that seemed to play a role when you could actually see the faces? And there were 2 regions that emerged. One was the dorsolateral prefrontal cortex, and I'll talk about what these regions do in a second. And the second was the anterior cingulate cortex. So these showed greater activity when you had conscious perception of the faces. And we had to ask the question, could these regions play a role in inhibiting the amygdala response? When you had an implicit association that was strong and that was not in line with your goals and beliefs. Consistent with this was another study by Jen Richardson around the same time, who showed that depending on, for individuals, white individuals, when they were looking at black versus white faces, the stronger your pro-white bias in the IAT, the more activity you saw in the dorsolateral prefrontal cortex and the anterior cingulate. So let me just go through what we think these regions are doing. So these are two regions that we see in a lot of studies of human brain imaging. The anterior cingulate is a region that we think is involved in conflict detection. The dorsolateral prefrontal cortex we know plays a role in the cognitive control of emotion. So what we think is going on here is when you particularly when you have a strong, say, pro-white bias, and you have egalitarian beliefs, the anterior cingulate may detect the need for the regulation of the implicit attitudes. There's a conflict there, and may send a signal then to the dorsolateral prefrontal cortex that works to then regulate your implicit attitudes in a manner more consistent with your explicit attitudes, with your beliefs. So this work sort of led us to sort of start to build our model of the neural systems of implicit race bias. And just to review, we have a socially relevant stimulus in the other race individual. If there's a conflict between your implicit attitude and your explicit attitude, we see responses in the anterior cingulate, which then signals the dorsolateral prefrontal cortex to perhaps regulate the expression of your implicit attitude in the amygdala somewhat. So this is the neural model I'm going to talk about in the rest of my studies. And sort of we're building on top of this. All right. So this suggests to us that at times we may unconsciously attempt to regulate the expression of our implicit attitudes to be in line with our egalitarian goals, with more or less success, obviously, because we still see expression of implicit race bias. So now I want to move to the second part of my talk. I want to ask the question, can we take advantage of our understanding of the neural basis of implicit race bias to enhance our understanding of race interactions? And I'm going to focus on two topics. One is learning about others, and the second one is making decisions about others. So what about learning about others? Well, here I'm now going back to the literature on the amygdala and what the amygdala does in emotional learning. And one of the things we know about the amygdala is it plays a role, as I already told you, in threat conditioning. There's simple associations between a neutral stimulus and a shock. But we also know that some stimuli are more likely to form strong threat associations. And when now that stimulus no longer predicts a threat, and we call that extinction learning, so I have a stimulus that predicts shock, and now I stop giving the shock, eventually the organism learns that stimulus doesn't predict a shock and stops responding. But that type of unlearning, that changing that response, is actually now harder for these prepared stimuli. It's almost like once you learn one of these things predicts something negative, you hold on to that learning more strongly and for longer. And that's what we call prepared stimuli. So the types of things we call prepared stimuli are things like spiders and snakes, whereas if you're using a control for this, you use something like a bird or a butterfly. And it's argued that this notion of prepared learning plays a role in phobias, and that these things where we show these stronger threat associations that are harder to get rid of are actually evolutionary threats, more likely to be an evolutionary threat to our survival. And so let me just give you an example. So we just replicated a standard finding of prepared and unprepared learning. So here, if we did a simple threat conditioning procedure, one stimulus that is a prepared stimulus, here the snake is paired with a shock. One of the unprepared stimulus, here the butterfly paired with shock. This is our baseline condition, right? So we're always comparing responses to these two stimuli. And then again, I'm measuring the skin conductance response to the stimulus paired with shock, subtracting out the response to the stimulus not paired with shock in that same category. What we see is this is sort of the replication of the classic prepared fear learning effect. Here's the fear relevant stimuli in red, the fear irrelevant in green. Here's the difference between the skin conductance response between the two stimuli. Here's when the stimulus is still paired with a shock. Here's when I stop presenting the shock. Very quickly, for the fear irrelevant stimulus, you learn that this thing is safe. But for the fear relevant stimulus, this learning is stickier. It hangs on, even though you're no longer getting a shock when you see those stimuli. So we asked the question, so one of the things about prepared stimuli is, much like other race faces, they also show amygdala activation that's greater when the stimuli are presented unconsciously, subliminally. So we asked the question, do other race faces look like prepared stimuli in threat learning? So here in this study, and here in this particular study, we had both. This was done when I was at New York University. We had both black and white participants. And we had 2 white faces, one of which was paired with shock, the other was a baseline. 2 black faces, one paired with shock, the other a baseline. And what we saw was, again, so slightly better acquisition when you are, that means stronger fear responses, when you have an out-group member paired with shock versus an in-group member. And that learning is more sticky. It's harder to change that learning once the stimulus is now safe. Now, if we break it down by the race of the participants, what we see is we see this both for the black and white participants. If you look at this data, it looks a little bit like the black participants show a slightly less strong effect than the white participants. We also asked questions, what factors are linked to the strength of these effects? So we asked things about IAT, we asked things about contact with other races. All of these people were in New York, so obviously they have a lot of experience with other races. And we found that only one factor, all of those were sort of correlated, I should say. Acquaintances, friends of other races. But the only one factor significantly and actually completely eliminated this effect, and that is if you've dated somebody outside of your race. If you dated somebody outside of your race, you didn't show any bias whatsoever. So here I'm just taking out participants with no interracial dating experience, and they have very equivalent, the black participants and white participants have very equivalent levels of prepared learning bias. I should point out that about half of our black participants had dated outside their race, only about 25% of our white participants. We assumed, given that the black participants were a minority at NYU, this was due to opportunity. We don't know. But what this suggests to us, right, is that there may be a preparedness to associate negative outcomes with out-group members, and these negative associations may be harder to change with new information. And that contact with others may alter perceptions of in-group and mediate this effect. So we were inspired to do this study by the prepared fear learning literature, which suggested there was an evolutionary bias in our learning. Things that could have been natural threats through evolution were more likely to hold on to negative associations with those stimuli, and it's going to be harder to get rid of those negative associations. When we think about this applying to out-group race faces, we don't think it's about race per se. In part because we believe the evolutionary argument, we didn't evolve in multiracial groups, right? We have multiracial groups because different human lineages went different places, but we didn't evolve that way. But we did evolve in groups or tribes. And you can imagine whatever your group is relative to your out-group, that the people in the out-group are going to be a more natural threat to you than people in your in-group. So we don't think this is about race per se. We think it's about the fact that in American culture, race is one of the primary ways we divide up our social groups. And I should point out, there was an evolutionary psychologist at Harvard, Jim Sedanius, who became interested in these effects. And he said, if this is true, and if there's an evolutionary basis for this, we'd expect to see it more with the male faces than female faces. And so he did the same study with female faces, and he found that was the case. We only saw this effect when we had male faces. So we know that contact with others may alter these perceptions of in-group and mediate these effects. And again, we only found it for dating. Dating, however, was related to IAT, was related to other forms of contact. But you can imagine once you date somebody outside your race, that may drastically shift what's your in-group and out-group, right? If dating is linked to mating, that may shift what you now consider your in-group and out-group very significantly. So what about decisions about others? Do these types of biases play a significant role in the choices we make about others? So I'm going to give you three examples of decisions about others, two from the economic domain and one just about the cause of behavior. So the first one was we were looking at decisions to trust. And we were, again, inspired by the brain data. So I've mentioned to you, the amygdala is thought to be a brain region that responds to threat. And along those lines, it also responds to untrustworthiness. If a face looks untrustworthy to you, you're more likely to show a strong amygdala response than if a face looks trustworthy to you. And in fact, patients with amygdala damage tend to rate people as more trustworthy overall. And so here's our work on implicit bias. Oops. And here's studies looking at sort of how the trustworthiness of faces leads to amygdala activation, comparing untrustworthy versus trustworthy faces. So this led us to ask the question, is race bias predictive of economic decisions to trust? So here we use what's a standard behavioral economic game called the trust game. People were shown faces like this. They were shown a total of, I think it was like 290 faces like this. 100 were black, 100 were white, and 90 were other races. And for each participant, they had to make a decision. It went something like this. Here's your partner. Your partner has, you have $10. You can choose to share some of this with your partner. So you might choose to share $7. Okay? If you choose to share $7, now you have $3. But your partner is going to get $28. We're going to multiply that times 4. Or you can keep your money, and now you have $10, your partner has nothing. But if you share, your partner now has a choice. The partner can reward you for your trust and give you half of the money that your partner earned, or your partner can keep the $28. So if you trust the person, of course, you make more money if you share because you expect your partner to reciprocate. So what we found, so here I'm plotting the implicit race bias. So I should say this was a large group of participants of all races. We tend to see more variability in implicit race bias if we include all races. And so we have a lot of variability in our implicit race bias. And here's the offered disparity. So in other words, how much more money did they give to individuals that were black versus white? And what you can see is a nice correlation. So here I'm just going to walk you through a couple participants. Here's an individual with a relatively high pro-white bias. Here we get from sort of the 0, $2, $4, $6, $8, $10. On average, how much did they share with white partners versus black partners? So they share much more with white partners than black partners. Here's somebody with a sort of more modest but pro-black bias. And here they're sharing slightly more with black partners than white partners. So this suggests to us that the higher the pro-white bias, the more you invest with white partners relative to black partners. Again, these are people you don't know anything about. We then want to ask, so in theory, if you are biased in whether you trust somebody in an economic situation, that may lead to an economic consequence for you, but it's not really apparent immediately that that's the case. So we want to ask the question a little bit more directly. What if there's clearly a personal cost to you if you're biased in your decision making? So to do that, we did another game, a classic economic game called the ultimatum game. And the way this works, so again, you had participants, we had about 290 partners, 100 black, I'm sorry, not 290, we had 160, 60 black, 60 white, and 40 other race. The way this ultimatum game works is your partner makes an offer to you. They have $10, they can split it with you, however they want. So this guy has $10, he's offering you he's keeping $7.62 and offering you $2.38. The only thing you can do is say no thank you. You can say yes, I'll take it, you get you $2.38. But if you say no thank you, you don't get your $2.38, but this guy doesn't get his $7.62 either, right? So in other words, so there's really no reason, given that you're never playing with the same person twice, there's really no reason to reject an offer because you're just losing money. But economists have shown in many, many studies, when out of, say, about a $10 pot, people offer about $2, about 50% of the time, people turn the offer down. And that's true if it's $100 and $20 and so on. When it gets to be too much money, nobody turns the offer down. So when we looked at sort of the acceptance rate, so all the offers given by the black and white partners were exactly the same. The range of offers, I should say, were, all the offers were in the 0 to 4 range because we wanted to hover around that $2 mark. And when we looked at the acceptance rate, we saw that people accepted more offers from white partners than black partners. There's about a 5% difference. So if I'm black, I have to offer you about 5%, 5 cents more in each one of these games to get you to accept an equivalent number of offers as you would if I were white. And this was correlated with IIT just a little bit. It was only about 5% of the variance in acceptance rate. So will race bias persist if there's a personal cost? The answer seems to be yes. People will pay more to punish unfair black versus white partners. Last question, and this relates more to the legal context. This is decisions about why people did things, what we call attribution decisions. So is race bias related to decisions about the cause or attribution of behavior? So let me just show you how. So if I'm in New York City driving, and this guy cuts me off, I'd be like, hey, I'm thinking, you jerk, right? Or I could think, oh, I was rushed earlier today. You know, I totally understand. That guy probably has to get somewhere, who knows? So I can either kind of attribute the fact that this person cut me off to the fact that that person has a bad personality, that that person's a jerk, or I can attribute it to the situation. You know, something's going on that's happening that caused this person to do that. They aren't necessarily a bad person. When we think about attributions, what we know, and there's a lot of work in social psychology about this, is that people tend to overestimate the disposition in attributing the cause of behaviors of other individuals, particularly individuals you're not familiar with. This is called the fundamental attribution error. So the sort of automatic response by most people is that this is due to the disposition, the person's rude. We also know that, again, that this is called the fundamental attribution error of overweighing dispositional explanations for behavior. We also know that if you take more time, people are more likely to consider the situation. And it's been suggested that it requires cognitive control to now take that second step to say, wait a second, maybe the situation had something to do with this circumstance. And we've shown in a series of studies that requires the dorsolateral prefrontal cortex to sort of override your automatic dispositional attribution to consider the situation. So we did a series of trials like this. Saw pictures like this. Tom left the restaurant in a hurry without tipping the waitress. There's the behavior. Then you hear a situation. Tom's baby was screaming. And now you're asked, was this behavior caused by the situation? Or was it caused by the fact that Tom's rude or a jerk? And Tom either looked like this or he looked like this. And what we found, so here's where we have positive behaviors. How often, and here's where they're saying that it was more due to the disposition. Here it's more due to the situation. For positive behaviors, they're roughly equally likely to say it was due to the disposition of the person. For negative behaviors, they're more likely, if it's a black individual, to say that the behavior was due to the disposition than the situation, and if it was a white person. So negative actions are more likely to be attributed to dispositional factors for black versus white actors. If we look at the brain during this, here I'm plotting the amygdala signal when you're making attributions for black versus white participants. And what I'm seeing is for the negative attribution, for the negative behaviors, the pattern mirrors that what I see with attributions. So more bold amygdala response when it's a black actor with a negative behavior. No difference for positive behaviors. So this asks the question, do these culturally acquired amygdala-related threat associations contribute to this attribution bias for negative actions? And I'll get to that to try to answer that question in a second, because this is a correlation. So what about IAT? So here I plotted the IAT. It's either a pro-white IAT or a pro-black IAT. And here's the attribution ratings for black targets with negative behavior. And if they show more, if an individual shows on average more dispositional attributions for negative behaviors for black actor, they're likely to have a higher pro-white bias. Whereas if they show more situational, they show sort of no bias or low bias. If I look in the dorsolateral prefrontal cortex, I see a very similar pattern. So here's the IAT, pro-white, pro-black. Here's when they make a situational attribution for a black actor. Here's a dispositional attribution for a negative behavior. And again, more situational attributions for pro-white, for someone with a high pro-white bias, more dorsolateral prefrontal cortex activation. Again, this region is involved in cognitive control, so this begs the question, does making a situational attribution with a black actor require a greater need for cognitive control to regulate your implicit bias? And then finally, we just, these types of attributions are what they essentially do in court cases, right? Why did this person do this thing? Did they do it because the situation caused them to? Are they really guilty? Or did they do it because, they committed a crime, they had an intent? So we actually went to court TV to try to find a real life crime. And we showed people the actual video, but never showed them the face of the defendant, because we manipulated that. So here's a guy in Boston. There was a nightclub. The nightclub ended. People were in the street partying. He got scared. He shot a rifle into the crowd. This was a veteran who had a sort of an upstanding record. And Dan Quatnar looked either like this or like this. And what we found is that we asked, interestingly, people found both the black and white defendant guilty in this case, more often than not. But we did see evidence that the race bias linked to things like sentence length. And essentially, the higher the pro-white bias, the more likely you were to give a longer sentence to the black defendant than the white defendant. So I've suggested that our decisions to trust, punish, and attributions about the cause of negative behaviors are influenced by implicit race attitudes. Now I want to ask, how might we change race bias in the brain and behavior? So here's the part where I have good news and bad news. So let's start with the good news. We know something about the brain and how it represents race bias. What can we do to change it? So I just want to say there's many techniques that are out there that are successful. Many emphasize counter-stereotype information. Others look at sort of evaluative conditioning, pairing black with good repeatedly. Others are related to focusing on the individual or exposure to role models. So to give you some examples, here in our very first study when we did this, so I was kind of nervous. I didn't study race bias at the time, and I was going to publish the first brain imaging study on race bias, and I was worried people would try to say too much about it. So I insisted we do a second study. The first was unfamiliar others. The second was familiar and well-liked others. I have to say we had people like Bill Cosby in this set too. It was a while ago, yeah. What we found was when you knew the individual, when it was an individual who was familiar to you that you could say something about that wasn't about their race, we didn't see any consistent pattern of amygdala response and no correlation between amygdala and implicit race bias. So familiarity with an individual, when you think about them as an individual, it mediates some of these effects. Even if it's an anonymous person, if you focus on the individual, so here's a study by Susan Fisk, so they had people look at faces and they said, is this person, they asked them to categorize this person based on a social group. So one is age, and it's not race, but just any social group. Or say something about this person as an individual. Just having you focus on the individual reduced the amygdala response that we saw and its relationship to implicit race bias. Here's an example that's relevant to the court. So what's the effect of having other people around, role models, people that you interact with of other races? So here's a jury study. Here's the defendant. The juries are either diverse or not. And what you see is it makes a difference. So whites and diverse groups are significantly less likely to vote guilty prior to deliberation. It's thought to be to the fact that they're actually peers with other people of other races. And finally, we were trying to say, what's the neural basis of these interventions? So a gentleman named Justin Lau at Harvard looked at all the interventions out there. He found this was one of the most powerful. So we used this one to look at the neural basis of these interventions and how they work. And the way this one works is individuals hear a story about a white assailant and a black rescuer. And they're given strategies for response control and perspective taking and thinking about the story. And the control manipulation here is very weird. Is just reading a story about the history of a toaster. So this is a counter stereotype story, and here they're just reading about toasters. And what we see, so here's your IIT pretest, what you expect, this sort of pro-white bias based on the IIT. Here's the intervention, and here's your post-test, right? So if you read about the toaster, just practicing the IIT makes it a little faster, but it's sort of you eliminate any bias with the sort of counter-stereotype intervention. When we looked at the brain, we had two hypotheses. Could it be that, this intervention is actually upping your cognitive control? Or could it be that you're sort of shifting the representation of threat association sort of just even subtly or temporarily? So we'd expect to see enhanced cognitive control represented in the dorsal prefrontal cortex. If it's the threat association that's now being shifted, we expect to see that in the amygdala. So we looked at patients with dorsal prefrontal cortex or amygdala damage. And what we found, so here's the patients with, here's the patients in red with the, that's the dorsal, yeah. Here's the patients in red with the dorsal prefrontal cortex damage. Here's the patients in green with the amygdala damage. So the intervention reduces implicit bias for patients with DLPFC, but not amygdala damage, right? So what this tells us is that the amygdala, we may be shifting the amygdala representation, shifting the associations that you have, the threat associations in the amygdala, as opposed to increasing the need for cognitive control. So this may act to reduce associative threat-related signals in the amygdala, but not increase DLPFC regulation. All right. So the problem with all these interventions, there's lots and lots of them, they work really well. The problem is they do not last beyond a day or so, right? They're sort of temporary shifts in how you're responding. You come back a day later, no difference. And this actually reminds me of threat conditioning, where I started doing this work. So what we know is if I do conditioning, I pair a tone with a shock, and then I extinguish that learning. A day later, I sometimes see a return of the response to the tone, right? Pavlov called this spontaneous recovery. We know that sort of this extinction learning is not unlearning, that these things persist, right? And that it can be temporary. And so it's very reminiscent that these things do not last more than a day. Once these associations are acquired, you can get rid of them, but sometimes they're sticky. It's really hard to do so. So what we're doing now, we're spending a lot of our time thinking about techniques to reduce the expression of amygdala-dependent Pavlovian threat associations, using a lot of sort of sophisticated neuroscience techniques, and trying to see can we translate them now to interventions for sort of more persistently reducing implicit bias. And that's kind of where the science is now. So this is the question we're asking is, can novel techniques that prevent the recovery of fear responses in Pavlovian threat conditioning be leveraged to persistently control unintended race bias? We don't know the answer to that, but I just moved to Harvard, so hopefully we'll do some of that work in the next 5 years or so. So the last part of my talk, I talked about how we might change race bias in the brain and behavior. We know that exposure to counter-stereotype information works, but not for long. And now we're trying to leverage cognitive neuroscience studies of learning and emotion to develop novel interventions that may work better. So what I've convinced you of today is that maybe by combining psychological and neuroscience approaches to the study of race and attitudes, we can develop better techniques to diminish the unintended consequence of implicit race attitudes and better align our actions with our goals. That's where we want to go with this. We aren't there yet, but that's where we want to go with this. So I want to just take a second to thank the people that paid for this work, the people that did this work and inspired this work, and I want to thank all of you for your attention. Thank you.